the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
People joining the online seminar now. Again, Steve Eget, and it's great to be here tonight. I definitely owe a lot to Stevens and my time there, and always like to give back whenever I can. Next slide, Rup. So in addition to me, I'm just going to give a little bit of an introduction here. I'm really happy to be joined by both Peter and Rup, whom I work with on a day-to-day basis. So Peter is a vice president at WSP as well, and he leads our environmental engineering group in the Metro New York area. He has over 30 years of experience in environmental consulting, focusing on big infrastructure projects, permitting compliance, and mitigative design. He has his BS in geological science from the University of Albany, as well as a master's in civil engineering from Rensselaer Polytech Institute. And then also joined by Rup, again, who I've worked with for now almost 4 years. So Rup's a consultant in our environmental group, and he focuses on automation and AI applications. He has over 15 years of experience, project management and automation, and specializing in environmental projects. So I think you'll get a lot out of it today. So he has his Bachelor's of Science from the Guwahati University, in India, and an MBA from Sri Shardi Institute of Management in India. And just a fun fact is we actually hired Rup when he was in India, and we worked remotely together for almost 2 years before he came to the States. So I'm so glad that he was able to join us here in the US. So next slide. So again, our presentation is really today going to focus on AI and its application in the environmental profession. But to start off, we got to figure out what AI is, right? And it's that simulation of human intelligence, especially by computer systems. And that includes like learning, material, reasoning, and self-correction. So this all sort of goes into the definition of what we would call artificial intelligence. So, and again, sometimes the terms AI and machine language are used intermittently, but actually machine language is a specific type of AI where computer systems learn from data on their own without explicit programming. So a good, for instance, is you'd give a very large data set with expected outcomes to the AI model. And over time, it would learn from all that data and be able to go on to the next, produce the correct outcome. And we're going to get an example of some machine learning that we used in projects, again, without explicit programming. And again, I think we all can, at this point, hopefully, whether it's on our phones here, we all get a little examples of AI, whether it's when we call for customer service or we use ChatGPT. It's starting to become a pretty seamless part of our everyday lives. Next slide. So this, okay, the general uses of AI. So, so generally, what we're trying to do with AI in, say, a business application is automate tasks, traditionally done by humans. Some of these are customer service, data quality, data entry. So some of these very like repetitive tasks we found can be done very effectively with AI and machine learning models. And again, Rup's going to go over and Peter are going to go over some examples of that later on. And in addition to doing it faster is what we always say is more efficiently. I actually feel like the greatest kind of gain that you get by implementing machine learning or an AI is the accuracy that you have. Because sometimes with a repetitive task that requires a considerable amount of data entry, there's just inherent errors with that process. So by incorporating like AI and different and automation techniques into the process, what you can find is it's exception. Not only the speed goes up, but the quality greatly increases. Next slide. So I have a little, again, just to clarify a little bit here, again, with the AI, machine learning, and deep learning. I'm not going to go into it, but I think sometimes we use some of these terms intermittently, and you can see kind of, AI is more. We don't have a tremendous amount of data, whereas machine learning, you could have, hundreds or thousands of data points for the model to learn from and determine how it's, better outcomes. And then there's also that term big data, which is more of like an algorithm based on just loading, millions and millions of data points into the system, and it builds algorithms and equations to kind of express, outcomes that you're looking for. So that's not necessarily like artificial intelligence, but those algorithms can be, highly effective in predicting behavior. Next slide. So some of the disadvantages, now it's not a foolproof kind of a thing using AI. I mean, there are high costs, especially high setup costs if you're going to develop your own models and own back office systems for AI. There can be high costs associated with that. It is technically complex. You got to get, smart people like Peter and Rup to work on the systems for you and kind of work through the entire process to get accurate results. And again, this is something new, so we don't necessarily have a tremendous amount of talent who is using it right now. And I think so. What sort of we're hoping for is that some of the jobs that are displaced by AI, those individuals actually can learn to kind of develop the AI models. There is an environmental impact also of AI. We're going to talk about that a little bit, but that is actually something significant that I think just everybody should be aware of. And then also legal issues. You don't necessarily think about it maybe in the day-to-day, dealings as a student, but obviously if you use, say, ChatGPT to write a paper for DIBS, that's a no-no. Any kind of, but also goes in consulting and in business world. You really got to check. Doesn't always accurately spit out exactly what you're looking for. And then what we're also finding too is a lot of our clients actually in states are not allowing AI to be used in work products for them. So, that's it right now. It's, differs by state and by client, but I think that's something that we're going to run into a lot, moving forward. Next slide. So I spoke a little bit about, the environmental impacts of AI and this, um, it looks like a map of, the portion of the United States at night, but that's actually some of the data networks and data centers that are in existence right now, and that whole network that connects all of them. So and it does AI requires these complex data centers, Amazon, Microsoft, Google, and many other companies are building data centers all over the country. In fact, it's probably the number one largest growing type of infrastructure right now in our country. And these data centers, as you can imagine, use a tremendous amount of electricity to power them. And as the servers get more and more complex, they also require a lot more cooling. So it requires a lot of water to facilitate that cooling. So as more and more data centers go and they just develop more robust requirements, we're having a lot of electricity and water consumption. So you see right now, this is estimate that about 4.5% of the US electricity is being used by data centers. That's going to go up very quickly to over 10% um, in a few years. So, I know they're trying to make improvements in the amount of electricity that the servers consume, but it can't happen fast enough based on the data. In fact, um, they're actually reactivating a lot of nuclear facilities because that's the only thing right now that can keep up with the growing electricity demand of the data centers. And I think those are the main issues I think that people focus on. Obviously, there's carbon emissions associated with electricity generation and water consumption, but also green space. Not every single one of these is built on like a kind of use space that's being repurposed. Many of them are being built, kind of in green areas. So that's sort of ending that green space. And then also, the e-waste, these servers are being constantly improved. So it's fermenting a lot of e-waste that's, going to the landfill. So that's just something else to consider, when you're deciding to use AI. So with that, I'm going to hand it over to Peter.
Yes, good evening. Rup, I may have the next slide. Okay, so what we're really focusing on here with the applications is what we've been involved in recently, and there's been a really significant change in the use of AI. Like it's really beginning to take off in our business. I'm seeing a very large difference between a year and a half ago and now. And as we've been exposed to these tools and this intelligence, we've been experimenting with it, using it on different parts of our work and seeing, where it really improves efficiency or the quality of the product and where it doesn't. And it's somewhat of an evolving process. But what I would like to cover generally are two areas that AI seems to be, quickly applicable in a practical way. One is in generally communication reports and technical research, and the other is in construction phase applications. The first one in the communication and technical report and research areas is using RAG, retrieval augmented generation, correspondence applications, and then probably more importantly, right now, in terms of impact, is research and technology. And with construction phase projects, this is the large infrastructure projects in the New York City metro area. We're using it quite a bit on specification and submittal review during the early construction phase process, and also throughout for the whole duration of that construction phase project with field report and data management. And later, Rup is going to speak more to the field report and data management. That's a whole large, interesting application in itself. Okay. So I'm only going to touch on this briefly, but RAG, generative content, it's likely that a lot of people are using it, including yourselves, to various degrees. But what we're finding is that the large language model produces better output, enhanced results if we feed it customized data. So that might be relevant reports and technical information you have your hands on, that you're working with in that subject matter area, and as well as meeting minutes that you might have with your team or other key bullet points that you want to cover, discuss. And if you take those and with clearly instructing it how to uh, process that content in an outlined format for your use, using clear prompt engineering guidelines, you input that into the large language model and you obtain what I would call an augmented response versus just querying LLM. Uh, we find it works better if we have our own customized database of relevant documents and provide that to the AI, large language model before we seek a response. Okay, the next slide. So in the beginning, we did quite a bit with emails, especially long chain emails, and we would query it for action items and key points. Also, we looked and did a little self-reflection using AI in terms of positive tone and professional communication with others within the organization. And this isn't something that you necessarily would need to do on a continuing basis, but it did sort of create a little bit of a reset when you were evaluated objectively relative to what the large language model sees. And we use Microsoft Copilot, but it did help fine tune some aspects of communication to make it smoother and more productive. And we also used it to search for relevant topics or subject matter that was of interest to the project or the actionable items that we had in front of us. So that was with emails. We're still using that a bit. But more importantly, I'd say, the large language model, and you can use, this lends itself well to adding customized data, is very effective in quickly identifying federal and state regulations as well as local administrative requirements such as code to understand what related minor approvals might be required in addition to the higher level federal and state compliance. And this is quite handy if you're going to another state or an area where you haven't worked before. And it's really remarkable how quickly it can cut down that regulatory learning curve time and identifying the requirements. Typically in an hour or two, you could, parse out what might have otherwise taken a day or more. Of course, like with everything with AI, you have to check the references that it's giving you. We don't take it on face value when we get an AI response. We require it that it cite the references, then we go to the references and we check to make sure they're legitimate references as well as any information that we're relying on. But it truly speeds the search up quite a bit. And in that process, you can ask it to tabulate and compare information, which is very useful in analyzing what your next step is. So, okay, next slide, group. I'm going to talk a little bit about prompt engineering, and then I'm going to show how we're using prompt in real world examples. So it's really covering two aspects of using AI, but with AI, the prompt engineering is huge. Like it's really all about the prompt. And these points that are mentioned here, consistency, clarity, scalability, and efficiency are all very important aspects of that. I'm not going to delve into the detail of that. I think it's fairly straightforward. But one question that has come to my mind is, in terms of for thought about our profession and how it may impact it is, has the emphasis on answering and solving problems in some way really shifted to how we ask the questions, rather than the getting the answers. So I think our education serves us very, very well in asking good questions. Because we think about the equations that would be relevant and the process to solving the problem. But in my view, there's definitely been a shift to asking very well. Okay. Next one. So in the asking, I'm going to show you an example, prompt engineering as applies to construction submittals. But these points that we're identifying here are really relevant to any type of query that you might make, searching for an answer. One of the things that it might seem obvious, but it wasn't intuitive to begin with, is that when you ask, AI, Copilot, ChatGPT to review engineering plans, specifications, reports, it actually is really important to tell it to review the entire thing. So in this example, I'm indicating like page 1 through 21. It's easy to presume that it's going to review the whole document, but actually we found sometimes it gets a bit, I'm going to call it loosely, lazy in its thinking, and it gets part way into it and then doesn't review the whole document. That'll probably improve as time goes on, but it is really important to tell it to review the entire document, however you want to be clear about that, as well as highlight key sections in that technical literature documents that you want it to focus on. And you might specifically mention the codes and standards in it, or whatever it is, that's your subject matter. And if you're cross-referencing, you want to be specific about that. I'm going to talk a little bit more about a cross-referencing example shortly. And also asking for justification for missing items. This can be somewhat of an iterative process. I find it almost always is with AI. You ask a question, you might get 80% quality response. You iteratively ask it again more specifically where you think the response is weak. It improves. Usually after 2 or 3 quick rounds, you get an optimal response for what you're attempting to do. So just generally, okay, it's standardized prompt. In this case, it's applied to construction phase submittals, and also, like, here we're trying to implement like a management approach to submittals using AI. So there's a lot of information that comes to us when we begin a construction phase. And in this context, we want to ask it to analyze specific text and specification information, and organize it into a structured table where we can like quickly make sense of it in a practical way. So it's actionable. We are not overwhelmed with a lot of information that we could process a lot more quickly if it was well organized. So, and to accomplish that, we have to be clear in our instructions about how we want that high voluminous amount of information organized for us. And I'm going to show you an example of that now. So one thing I want you to picture, because I didn't want to overwhelm the screen with information, is, in a set of construction documents, you have your bid forms and you have your drawings and you have a construction specification. So the construction specifications, whether they're in written format for different areas of work, or whether they're on a drawing, which often happens in construction and infrastructure, where they'll take all the specifications and put them on a large 24 by 36 drawing. And you're faced with a lot of information that it might not be that well organized. There might be like subheaders of the topic, like clean fill, or, import, erosion and stabilization control. But there's a lot of information, and it is related in some way to each other, and it's not all sorted out the way you would like it to be sometimes. So this is an example of like clearly specifying the format that you want it to come to you in. So you feed those specifications into the AI model and tell it, we want these columns, which you see on the left, and we want this explanation for the information under each column, so that we can quickly process that information, act on it. And here's an example. So on the left there are RQ is, it's an abbreviation for requirements. This AI model has now processed those specifications, whether it was reams of specifications out of a set of contract documents, or whether it was on a drawings, for what you've asked it to look at. So it's taken those requirements and it's tabulated them, giving you a summary of the requirement, who's responsible, what the action is. And very importantly, in this particular example, we were very interested in the timing details, because in construction, a lot of it's about the timing. What should we be looking at now, pre-construction? What should we be looking at during construction? What should we be making sure happens at the end of construction, when we're getting into record drawings and closing a job out? So this was timing oriented, and that's why I bolded that column, because I wanted my team to know what to look at early during the construction phase, and then at the end to make sure they were acting on all the requirements. Okay, next. And that's okay. That's another table showing the same information in tabular format. So the next step was to filter and query all that information that had been tabulated into a way that we could easily see what to act on. But first, that table is organizing it very well, so we can see clearly in a tabular format what to act on, instead of it being buried in, hundreds or thousands of pages of information. We're getting that actionable information pulled, extracted right out and tabulated. And now is the when, right? So Rup, let's go to the next slide. So it simply gave us, what requirements were tabulated in that analysis by pre-construction start. So these are the items that we have to look at in the beginning. So that focuses our team right in on those requirements. And then as we progress, these other requirements become a new task list to monitor. And then finally, we have the closeout requirements under RQ10. That's a management approach. Now, this is a related example of a comparison of shop drawing submittals to specifications. And I understand the print is fine here, but I can illustrate the point. This is probably one of the most useful applications that I've seen to date. Like when we get a contractor submittal to show how they're going to comply, a shop drawing submittal, to show how they're going to comply with our specifications for a contract. Sometimes those submittals, they're not always up to snuff, and they might be fragmenting them and giving you the information in pieces, or they may give you the information and it may be missing something that is fundamentally required in terms of very important, or it might be something else that is less important, a lower priority, but you want to keep track of what that is. And what the AI does is, if you ask it properly, you feed it the specification that pertains to that shop drawing submittal they just made, and you ask them the model to compare the two. And in this case, and the instructions are, let us know what's compliant, what you see is compliant, about that submittal. Let us know what is partially compliant, and I've highlighted that as an example of an area that was only partially compliant. And then opine on, what is missing, and so to focus the technical reviewer on what is likely missing. So will not completely do your shop drawing review, but it will do it to 80% level, roughly. Uh, Sometimes a little bit more, sometimes less, depending on how complicated the submittal is. But then very importantly, what I'm showing over on the right is, as engineers and scientists, we have to QA QC that output. Like, we can't completely rely on it. So it is focusing us in on what is compliant and what's not, but we need to do a high level review, just like we were reviewing the work of one of our team members. So, we usually have senior engineers or technical directors doing QA QC, and the QA QC still has to happen, and that's what I'm doing right here. Looking at it and I'm commenting. You can see sometimes I agree, and sometimes I see things that need to be clarified, but there is a thorough QA QC of that. But this saves a lot of time in a very practical sense. So I've done shop drawing reviews in an hour that might otherwise take at least half a day. So efficiency, very high for this application. And there is a lot of this type of work involved in engine and infrastructure and energy projects that we all see happening every day in the New York City metro area and the surrounding region. There's a tremendous amount of infrastructure and energy work happening, and all of these projects that are agency projects, New York City agencies, state agencies, and also the private energy companies, they all require this type of review. So it's very impactful that this can occur. Rup?
Yes. Hi, everyone. Thanks, Peter. Yes. Okay, first of all, I'm so excited to be here. Yeah, first time I'm interacting with a education institute, and yeah, feel free to stop me anywhere you feel, marks anything. I'll just go through a couple of the AI use cases, how we are using the AI for the projects, for the project management, for the project delivery in different way. So I especially talk about for the data management point of view, how we are using the AI for data management. So this is an example of a AI report assistant, which is a multi-agent model. Nowadays, we have so many terms floating around: multi-model, multi-agent, AI model, RAG, Langflow. There are so many terms are floating around every day, and the changes are so quick. We just do something on one day, next day we find out there's something new. So yeah, it's like bit of sometimes challenging to cope up with. The best we have at this moment means whatever we could do best with the Microsoft. Microsoft is our technology partner, so whatever we do on the Microsoft side with the Microsoft Azure, Azure AI and Azure Foundry. Azure Foundry mostly provide all the any model you want to use, any model you want to host on the Microsoft side, you can host it, you can load it, and you can use the model anywhere. And if you want, you can also do the model training if you want to do the train. And if not, if you just want to get a rack solution, you can just put in the Microsoft service. It will use the rack solution with the model. So Microsoft have mostly all the options, and it gives a basically secure environment to work in with the AI models. And they have like 10,000 AI models with different training levels and different training specialization subject matter. So it's really exciting, and I hope you'll find it exciting too. So this is just a one report generator. We need to do some initial environmental assessment where we need to refer to different data set and create a report. So we created a chatbot where we can put a requirement, something like this very quickly, and it can create a detailed report. This is the main objective. And we have a large amount of data which we put with the AI model. So this is basically a multi-model RAG. So multi-agentic RAG. And so we have couple of AI agent here. One is data acquisition agent, which basically it is connected to the database which you created. And the Azure AI source is the main data set which we have. And we created from the all the documents and text, whatever available with us from the different government agencies. And environment analysis agent, regulator compliance agent, consultation recognition agent. Uh, After all these agents, it generates a report, the detailed report, including all the input from the agents. It's like the multiple people are working on multiple direction, give a feedback. This agent finally summarize all the feedback and create a report. So it's like a teamwork. You have a team of different agents which work together, get you data, and create a final output for you. And which can be the initial the draft we can work on. Definitely not the 100% one. Everything need to be reviewed, authenticated, looked through. But this can be the first draft which someone can start working on. And yeah, I just put this is basically a lang flow. I didn't want to show the code because it's like very boring. The lang flow gives a better idea how it's goes through the flow. So suppose these are your files and you are using the Azure AI embedding. The first of all, you split the text in different the chunk. You can define a chunk size that much you want, and there is a overlap how much overlapping you want. And this AI embedding will create a database and put it in the vector database MongoDB. Your all the data is saved in a vector database. This is called data ingestion. So basically, you are taking up all your data, whatever you have, and putting it one place as a vector database, and which can work as a like the help book, the guidebook for the AI. Because the AI models, the training data is not very updated. Maybe the most recent or maybe 6 month old. The so different model has different training data. So definitely they don't have the updated data. That is one reason. And second reason, when you put your data, you definitely customize the AI output, how it going to react to your queries, react to your requirements. So instead of going for training the model, which is like a more complex and more expensive thing, the first thing can be started at like the RAG, where you provide your data. First thing, just ingest your data in the database in the as a vector database. And this database, when you are doing the data query with the database, so you're using an OpenAI embedding, and it query the database. If you get a chat input, it query a database. You suppose you also have a this is another agent which do the query from the internet resources, whatever we need, whatever we're asking. So first you have a data which we have already provided. Secondly, is has the online resources available, which is current, new, updated. So it goes the both, and it finally goes to your data, the language model. So whenever language model is responding to a query, so it is using your database data, it is using the online data, the available whatever you have customized, and then finally it is giving the response to your question or to a requirement. And this can be the whole thing can be used as a single agent, and you can have like multiple agent for each work, and you can orchestrate in a way something what come first, what comes second, what come next. So you can do the orchestration so that it works in a sequence one by one, One agent respond, the second another take the response and give the response to the third one. Third agent take the response from the second one, give the response to the fourth one. So it can be orchestrated step by step any way you want, right? So this is basically Langflow. You may have already using it. Open source, very straightforward. You just need to put your API keys. It will work simultaneously. And you can say it is kind of if you're not very good at like Python, it is a good place. Can be a good place to start with. Very user friendly, open source, and can be is scalable. So next one is the data management. So this is the example of the bridge project, which is one of like $1.5 billion projects connecting US and Canada. And here we basically use AI for managing the data of the concrete books. You know, when there is the bridge is being built, thousands of trucks load of concrete are coming through. And as a consultant, we need to do the testing of all the concretes and is it a acceptable limit or not. So it's like a huge and daily basis, hundreds of trucks are coming every day delivered, used, and we need to do sampling for a certain amount of all the each and every concrete truck coming to the site. So one way we first use, just like whenever a concrete comes, it gives a receipt, which gives like the quality testing data from the point of view of the vendor. So we have a guy at the site who click a picture with a phone and just put it on database. This is the first step, right? And the second way, so we have basically two main method. One is fully automated, unattended. Second is semi-automated. This is where I started semi-automated. Here is a mobile app or a computer where people can upload the documents. So they're basically uploading the files, the pictures, the PDF files, which have the quality data of the concrete books. So as soon as they upload the data in the mobile app or in the computer anywhere, the AI runs through the each and every file which is coming through. So we're using for GPT 4.1, and the Python script is being run at the background to scrap the data. And we save the data finally in the SharePoint. And this SharePoint data we finally processed in a ticket database, which we call concrete ticket database. So this is semi-automated process where you're using a mobile app or you can use your desktop to upload the data. So in this case, we set up the AI once. We know what kind of format we're receiving. We know what kind of things we need to get from the data. So we train the AI model as per our documents, and because the formats of our supplier are standard, we have a couple of suppliers, we know what kind of format they are providing data. So we train the model so that they can convert those PDF files into like tabular format, which can be used for reporting. And they convert a table and put it in the database as a SQL table. There's the first step. And for fully automated part, we have two way. One is the email in the shared mailbox. If in some vendors, whenever they deliver a truck of concrete, we automatically receive a email with the QC document of that concrete truck. So what it does, as soon as it's received our email in our inbox, we set up the AI model, which can automatically read through the attachment of the email. So it goes through the file, scrap the data, create a table, and put it in a database. So this is completely unattended. They automatically send us a PDF file. We read the file from the email, and it put it in the AI run through the each and every attachment of the email and put in the database. And second option is the SharePoint library. The same concept, we have a common space where the vendor can upload the supplier can upload their all the quality documents. They can upload the bulk, maybe 1,000 files at a time every day. So this some vendors upload it directly onto the SharePoint site. As soon as they put in the SharePoint library, The AI will run through each and every, the AI model is run through each and every file which they uploaded, and then it will create a table and put it into the database. This database is connected to our dashboard. So as a result, on the real-time basis, our QC manager can go to the dashboard and look at how many trucks has come and what is the quality document they are providing. So this is all the supplier side what we're getting the data with the help of the AI. On the other side, we also have the testing data of our own of all these concrete books, right? So what we do, we use the AI model which can read this concrete testing data we are receiving from our labs. It also read the data which is submitted by the supplier. Using the both the data, the AI model generate an automated report, which is basically a means quantifying. Suppose they submitted 100 trucks of concrete. We don't need to do 100. Maybe we do 10%, 10. So every concrete book has a concrete ticket. So it will check the concrete ticket of from here from the supplier. It will check the concrete ticket from our testing data, and it will create a common table. Means this is the final report which has the quality data of only those concrete tickets which are tested, and it will compare the both the quality uh, measurement provided by the supplier and quality measurement we found from the testing data. And this will then send an automated email to our client, to our project manager, to our QC people for further review. So this was a complete end-to-end workflow where we used AI in multiple stages to process the data, to get it in a shape. Initially, they started picking up the data manually one by one, which was like very big data and humanly not possible. And it really helped. And after all, it was a good project at the end. This is a kind of data it creates on the real time basis. Means whatever the data it is reading from the supplier side, vendor side, it is reading as putting it in the database. I just said the supplier name because a lot many supplier. So this is the final output, what AI is doing background at the backend and what they finally got to us, right? And we can go anywhere and do the QC. If we find any mistake, we can go to the database, make the changes. And there's also a link to the each file. I can open the file and look at what is the file is about and what the AI is reading. So QC is very much important each and every stage. If you are doing like 2000 entries every day, you have to do at least like 5% minimum for QC, because sometime also there are some documents which are handwritten where the accuracy goes down. If there's a handwritten, they have different handwritings and they write the thing differently. So that's sometimes a challenge. So there you need to maintain a QC level for like 10% every time to manage the accuracy as much as possible. Uh, yeah. So with Microsoft, the AI is available from 2.1 is you can use within Power Automate, where you can use the prompt and convert anything, create anything. Suppose I receive a email in my inbox, right, from Peter. I can create a prompt, create out of the flow to reply to the Peter if I already know what Peter is going to ask me. Right. So the first place, the easiest place to use in the Power Automate, where you have the model inbuilt. So Microsoft has a beautiful way of organizing the things and helping the corporates to manage the workflows. So Power Automate is one of the best way and most efficient way and the lowest cost way of using the AI. And it can do repetitive work. The Power Automate can do repetitive work. Suppose I need to analyze 10,000 rows of data, right? And I want to put one comment against each data set. So I will put a Power Automate flow which will go through each line, each row, and put a comment as I recommended, as I set up earlier. So this is so easy, so straightforward, and it's really helpful even with the lots of operational things, day-to-day things. It really worked well. So you can use it content creation, replying email, replying the feedback, replying survey, you name it. Any business process, you can use the AI with the Power Automate flow, and it make the things efficient. I can also remember one another app which we did for another project for health and safety data. It was like there's a mobile app. The people go to the site, submit the mobile app data. The AI go through the data and can create automated report from the backend. So you name it. There's each and every business flow. You can use AI and make it efficient as much as possible. So data analytics. I would say means it needs some more training, more data, more fine tuning for get a very good data analysis. But this is one of the best for content creation and augmentation, which Peter has also described. Data analysis still some, I think some this distance to cover till now. And as we don't uh, basically train the data, we just do augmentation. So that's sometimes a problem for us for data analysis, and going just inside the everything to the deepest part of the data is sometimes challenging. But as we are getting new models, we previously we have 4.0, now even 4.1. So they are getting better. I'm sure in very soon they will be best. And another challenge is like the token context means they have a limitation of the token, how many token you can use at a time, right? Means suppose you put a 50 pages document in a Power Automate flow to go through everything. So that will be very difficult because there is a limitation of tokens, how many it can consume at a time. So that is set from the admin side. We can increase the limit, but there is a catch. So best to use the smaller documents, just like divide it, make part by part. So up to 10, I think up to 10 pages, it works well. If you are going beyond 10 pages, it sometimes miss out some pages beyond 10 is number 10. Summarization, yes, the same case means definitely a wonderful output all the time. But document size sometimes a problem, but it's improving. You can classify the content. Just for an example, means when companies are dealing with the clients, means you can set up a AI bot at the email side. Means client is sending emails or asking you something. So the AI is go through each and every emotion what the client say. It can figure out if the client is angry or the client is happy. So if client is angry, it can notify the client seems angry. So it can notify the PM, it can notify the project director, so they don't know something is happening not good. So that's like who works remain in the background but still keep working without us knowing anything. So that can be a very good example how AI is used by corporates. And yeah, software coding, content classification. You can classify the content as you can describe everything in natural language. So that is the best part. So previously, when you want to automate something, the biggest hurdle was that you need to predefine everything. You need to do if else, if else, if else for hundreds of thousands of times. But in case of AI, at least you can get rid of those. Very straightforward, very quick. Speed is very high, and it's all about speed. I love it, and I'm sure you will also love it. Thank you very much, and really appreciate the time. And thanks everyone. Thanks Peter. Thanks Steve.
Yeah,
Hey.
thanks a lot, Rup.
Yeah, absolutely.